Hello and welcome to Primary Math 6. We're going to start in Workbook 6A, working on Exercise 1, and we'll use a textbook, pages 6 through 9, so you'll want to have that out and open before you. Before we start, I want to give you a kind of a heads up. Every year so far in Singapore Math, you have started your first week of Singapore Math talking about whole numbers and place value and digits. This year, we're starting with a new topic, and it's not one you've done before. It's the topic of algebra. So the first few weeks are going to feel new to you. Instead of a review, you're all of a sudden jumping into a brand new topic, and there's only 3 exercises on algebra, but you'll want to pause and think and make sure you understand this, and then we'll go on to other concepts from there. But we start off with algebra. Before we talk about anything in the book, I just want to remind you or tell you for the first time, since this is all new to you, that a variable is a letter that represents a number. So when we have a letter in a math problem, it's called a variable, and all that letter is something that's standing in the place of a number. Another thing to understand and to know the term of is that sometimes we give an answer and they say, give the answer in terms of a variable. What that means is that the answer is going to have a letter in it. We'll do some examples of that in a minute, and I'll show you what it is, but just notice when you see something that says, give the answer in terms of, that's your cue in your mind to think, oh, I'll have a letter in my answer. All right, on page 6 in the textbook, you see a chart, and it talks about Angela's age and Lamai's age. If Angela is 6, we know that Lamai is 8. If Angela is 7, we know that Lamai is 9. If Angela is 8, Lamai is 10. You can read the chart. So what we can notice here, and this happens all the time, I bet you know somebody that is 2 years older or maybe 2 years younger than you. 6 plus 2 is 8, but when Angela turns 9, 9 plus 2 is 11. Every year, since both of them add 1 year every year to their age, each of them goes up by 1 every year, and that means that Lamai is always Angela's age plus 2. So we could ask a question like this. When Angela is 12, how old is Lamai? Well, 12 add 2 is 14. Lamai is 14 years old. The next question on page 6. When Angela is 15, how old is Lamai? Well, if Angela is 15 and we add 2 to Angela's age, we found out that Lamai is 17. And then we start thinking about a letter. What about when Angela is N? How old is Lamai? Well, every time we start with Angela's age, which now we're being told is N, and we add 2. Now, the different thing in algebra is I can't answer that with a number because I don't know what N represents for this problem, but whatever Angela's age is, add 2 and you'll have Lamai's age. And so then they say, well, when N is 16, N plus 2 is the same thing as 16 plus 2. That's 18. So if Angela is 16, Lamai is 18. And then we could say if Angela is 20, N plus 2 is Lamai's age. 20 plus 2 is 22. That would tell us what Lamai's age is. So when we talk about Lamai's age is N plus 2, it's just a really convenient way of talking about the two ages and comparing them together. Now let's look at page 7. Look at the top of the page, number 1. It talks about Alan being 8 years old. Now, if Alan is 8 years old, what happens in 5 years? Well, of course, he's 8 now, and if he adds 5 years to his age, he'll be 13 years old. What if he's 8 years old now? How old will he be in X years? Now we have a variable instead of a number, and I can say that he will be 8, which he is now, and I would add X, and he would be 8 plus X years old. See, that is an answer in terms of X. Do you see that on the next part of the page? It says, how old will he be in X years' time? Give the answer in terms of X. Now you'll notice the little dude in the ball cap, he doesn't say 8 plus X, he actually has an X plus 8 in his thought bubble. But we know that when you have 2 plus 7, that's the same thing as 7 plus 2. They're the same answer. So anytime you have addition, if we say 8 plus X or X plus 8, it's the same answer. So it doesn't matter which way you write it. Look at example number 2. Jim has $2 more than Travis. Part A says Jim has $10. Travis has how much money? Well, if Jim has more than Travis, if I start with Jim's dollars of 10 and I subtract the 2 that he has more than Travis, I get a smaller number, and that makes sense because if Jim has more, clearly Travis has less. So Travis has $8 if Jim has $10. But letter B tells us that Jim has M dollars. How much does Travis have? And again, we're going to give our answer in terms of M, which makes sense because I don't know how much money Jim has. I couldn't possibly tell you how much Travis has, but I do know that whatever Jim has, subtract 2, that's going to be how much Travis has. We usually put parentheses around it because it's M minus $2. That M minus 2 is a single number. Now remember, 7 minus 2 compared to 2 minus 7, they are not the same thing. So with subtraction, you have to make sure to get the correct number in the first spot. So if Jim has M and he has the most, you would have M minus 2 to find Travis's. It's important to have M minus 2, not 2 minus M. Keep going on that page. Look at number 3. Tracy bought W kilograms of flour. I don't know how much she bought, but you know what? I could kind of draw a picture and say, okay, here's what she bought, and it's W kilograms. And then I know she used 5 kilograms. That's gone. We want to express the flour she had left, that's this part, in terms of W. Now, if that feels new and strange to you, I want you to remember that we've talked for a very long time about the fact that a part plus a part is equal to the whole, and we've said if you know the whole and you know one part, you can subtract them to get the other part. And so that's exactly what I have. The whole thing that she bought is W kilograms. The amount that she used is 5 kilograms, and if I subtract those, what she has left is that other part in the picture. So the flour that she has left in terms of W, we would write W minus 5, use a parentheses, and put units. Of course, we're still going to put units. We never stop putting units. And then we have Tracy bought 8 kilograms of flour. How much flour did she have left? Well, if what she has left is W minus 5, where W is how much she bought, 8 minus 5 is 3 kilograms. If she bought 8 kilograms, then what she has left is 3 kilograms. And yes, you could have just said she bought 8, she used 5, that means 3, but I went ahead and wrote it using the idea of the variable to show you that if I know what W stands for, it stands for the number 8, then I can just use the W minus 5 expression and put in the 8 and find out how much flour Tracy has left. look over on page 8. We're talking about packets that contain 4 apples each. The first question is we're trying to find out how many apples there are in n packets. N is your variable. So the problem is I'll never know how many apples I have if I don't know how many packets I have. So my answer is going to be in terms of n. And then we're going to just think for a minute. If I have 1 packet, I multiply 4 times 1 to get 4. There's 4 apples in 1 packet. If I have 3 packets, I have 4 3 times, because there's 3 packets and 4 apples in each one. 4 times 3 is 12. I have 12 apples. If I have 5 packets, since 4 times 5 is 20, there would be 20 apples. So then here's a question. If I have n packets, what do I do to find the number of apples? Well, every other time I took 4 and I multiplied it by the number of packets I had. And this is no different. I'm always going to take the number of packets, which is n, and multiply it by 4. Now, let's talk about proper etiquette in math. We generally don't write a multiplication sign because it gets kind of confusing. Maybe that's 4xn. Maybe x is a variable as well. So we don't normally write a times sign in the middle of an algebra problem. We just put 4n side by side. Because remember, 4n means n plus n plus n plus n. We do mean 4n. That's the same thing as 4 times n. Think about that for just a minute. If I had 6 plus 6 plus 6 plus 6, that's the same thing as 4 times 6, which is 24. So when I write 4n, you can think 4 times n, or you can think n plus n plus n plus n. It means the same thing. And so let's continue with part B. If n equals 8, how many apples? Well, if there are 4 apples in each packet and there are 8 packets, we've already said 4n is the number of apples. If n is 8, I just put in the number 8 in place of the letter n. 4 times 8 is 32. There are 32 apples in 8 packets. What about if I have 11 packets? How many apples are there? Whatever the number of packets is, I multiply it times 4. So 4 times 11, that tells me there are 44 apples. Very simple, not confusing. Let's keep going on page 8, number 5. In this problem, there are 3 boxes of chicken wings, and each box contains P wings. I don't know if there are 2 wings in a box, or 22 wings in a box, or 220 wings in a box. I just know there are 3 boxes, and each one of them has P wings. So we're asked to express the total number of chicken wings, and there's the phrase, in terms of P. I'll have a P in my answer. Of course I'll have a P in the answer. I don't know a number. I'll have to have a variable in the answer. How many total wings do I have? Well, I have P in the first box, P in the second box, and P in the third box. The easiest way to write that is just to say I have 3 P wings. Again, we don't get confused when I say 8 plus 8 plus 8 is 24. 3 times 8 is 24. Somehow this may feel a little confusing. How did you go from addition to multiplication? But when we say 3p, we just mean p plus p plus p, just like 3/8 means 8 plus 8 plus 8. If you ever feel confused doing algebra, just take it back to numbers that you know. The rules don't change. It just looks funny to our eyes because it's in variables instead of in numbers. So the total number of wings in terms of P, you actually could put P plus P plus P, but this is the shortest expected answer. Part B says, if each box contained 7 wings, how many wings are there altogether? Well, we said that all the wings altogether, I should start by writing 3P, we've said there are 3P wings altogether, and they're telling us P is 7, because there are 7 wings in each box, so 3 times 7 is 21 wings altogether. Page 9, number 6, talks about having a rectangle that is k centimeters by 8 centimeters, and we're going to express its area, again look at the phrase, in terms of k. Area, the formula is to take the length, multiply it by the width. In this case, I don't know the length, I do know the width. And so the normal format for k times 8 is just to call it 8k, and units, because it's area, we know are going to be square centimeters. So the area is 8k square centimeters. Number 7, Ollie has 8 boxes. He puts an equal number of marbles into each box. Part A says, if there's 96 marbles, how many marbles are in each box? Well, I know that I have 96 marbles divided evenly into 8 boxes. If I do that division, I would find that there are 12 marbles in each. All right, so if I know the total number of marbles, I can divide them, literally divide them into 8 boxes and find out how many marbles are in each box. So look at part B. It tells us there are X marbles, and we want to find the number of marbles in each box in terms of X. I can't find an answer because I don't know the number I'm starting with. But just like on the problem above that, if I started with 96 marbles, I put them all in a group, and then I divided those 96 marbles evenly into 8 boxes. This time I start with X marbles. I'm still going to divide them evenly into 8 boxes, and so that's how many marbles in each box. That's a really good strategy for when you're starting to think about algebra, is to use a problem with numbers and then think about how you would do it if you didn't know the number. Again, we were told there's 96 marbles altogether, and we knew to do 96 divided by 8. So if there are X marbles altogether, we know that you're going to do X divided by 8. Let's use that same strategy on number 8. Meihua bought 3 books. If the total cost of the books is $12, find their average cost. Well, if you paid $12 and you got 3 books for it, on average they cost $4 each. Now we don't know. Maybe one book was $10 and the other 2 books were each $1. We can just talk about the average cost. If you said Meihua bought 3 of the same books, right? Buy 3 books so you can read one and give 2 to friends, then we'd know they'd be the same price. But in this case, notice we don't know they're the same price, so we can just talk about the average cost. Then look at part B. If the total cost is M dollars, find the average cost in terms of M. Just like when we knew the total cost was $12, we started with the 12 on top. When we notice that the total cost is M dollars, we're going to start with an M on top, divide by 3, and I know that the average cost is going to be M over $3. I don't know what M is. Again, I've given the answer in terms of M. The last thing on page 9 is number 9, and it is not a difficult thing to do. We want to get in the habit of substituting a value in for a variable to solve. So if I have n plus 4, and I'm told that n is 6, 6 plus 4 is 10. 10 plus n becomes 10 plus 6, which is 16. 15 minus n is 15 minus 6. That, of course, is equal to 9. N minus 6 is the same thing as 6 minus 6. That's 0. 4n means 4 times 6, certainly not 46, right? It's not just that you write a 6 next to it. This means 4 times n. So 4 times 6 is 24. 10n, same thing, means 10 times 6, that's going to be 60. N over 2, 6 over 2, a fraction always means division, and so when we divide 6 over 2, that's 3. N over 6, 6 over 6, a number divided by itself is 1. And lastly, n over 12 is 6 over 12. That's the same thing as 1 times 6 over 2 times 6, so the 6's cancel, and I'm left with a reduced version of 1/2. Now, all of that is true when n equals 6. If you made n equal 7, you would have a whole different set of answers. All right, so all of that kind of gives you an introduction to the idea of algebra and how to use a variable, how to give an answer in terms of a variable, and you're all set now to do exercise 1.